In lesson 11.5 here, we're going to be learning about what's called the factor theorem. So our targets in that lesson are to 1, be able to find 0 of polynomial functions by factoring. So you know we've been spending a lot of time doing that in this chapter, so we're going to use that to help us find some things on a polynomial function. We also want to be able to determine the equation of a polynomial function by looking at some data points or a graph of that function. We want to be able to apply what's called the zero product theorem and the factor theorem to be able to graph polynomial functions and then estimate their zeros by looking at either the graph and where it intersects the x-axis or by using the table on our calculator. So we want to be able to solve this function g of x for x, and we want to do it using factoring. So the first thing we know to look for is the greatest common factor. Well, we notice that every single term in this polynomial is divisible by 3x. So I'm going to divide out a 3x. 3x cubed divided by 3x is x squared. 33x squared divided by 3x is 11x. And 90x divided by 3x is 30. So we factored out the greatest common factor. Then we know we want to go further if possible and continue factoring what's left in the parentheses. Well, I notice it's not a special case because it does not begin and end in a perfect square. But it is very easy to factor in that the leading coefficient is 1. So I know first times first has to equal x squared. Well, that would be x times x. I know that the sign here tells me that the signs in my binomials will be the same, and this tells me they'll both be negative. And finally, I know that last times last needs to equal 30, and in this case, they need to add up to negative 11. Well, negative 6 times negative 5 is equal to 30. So my factors must be x minus 6 and x minus 5. Now, if you notice in my polynomial, g of x, we should notice that we're multiplying 3 things together. We've got 3x being multiplied by x minus 6 being multiplied by x minus 5. If any of those 3 things was equal to 0, then the product, the entire product for the polynomial, would equal 0. So what the zero product theorem tells us is that if any of those 3 terms is equal to 0, then we would get a product equal to 0. So what we need to do is determine what values of x would make that polynomial equal to 0. In other words, we want to take each of those factors, the 3x, the x minus 6, and the x minus 5, and set them each equal to 0, and solve for x. So to solve 3x equals 0 for x, we would need to divide both sides by 3, and of course x would equal 0, because 0 divided by 3 is 0. To solve x minus 6 equals 0 for x, we'd have to add 6 to both sides of the equation, so we'd get x is equal to 6. And the last factor, we'd need to add 5 to both sides, and we'd get x is equal to 5. So we've determined then that if any of the 3 factors equals 0, we would get a product of 0, and therefore x can equal 0, 6, or 5. If it had any of those values, we would get a product equal to 0. So here we ask you to find the zeros of this polynomial function. The difference is this one is already in factored form. And we notice it has 4 factors: 5, x minus 2, x plus 9, and 3x minus 1. So what we want to do is set each of those equal to 0. Well, 5 cannot equal 0. So we're not going to be able to find a value of x there that would make this polynomial equal to 0. But if x minus 2 were set equal to 0, then solve for x, we'd find that if x were replaced with the number 2, this entire polynomial would come out equal to 0. So that is a 0 of the polynomial. If x plus 9 were equal to 0, again, we'd get a product of 0. So solve for x, and we'd get x is equal to negative 9. And finally, if 3x minus 1 were equal to 0, then we would have the polynomial equal to 0 as well. And to solve for x, we'd have to add 1 to both sides, and then divide by 3. And so we'd find a third 0 of this particular polynomial is x is equal to 1/3.